Oh, Lord, couldn't believe it. I thought it was taping. So, let's move on to section B. And what I said earlier was that even though it's the same type of test, it's the same type of test with the questions that are basically same. There's nothing different. It's not like this is the A or B section or matching section where the questions are asked are the same. But I guess this is section B. We call it section B, question 4. So for a popular amusement park ride, patrons board board a carriage at the top of a high tower and are subjected to a wild ride of terror. So name and state the Newton's law which applies if the carriage is moving horizontally at a constant speed in a straight line. Constant speed sounds like Newton's first law. And we say if a body is at rest, it stays at rest, but if moving, continues to do so at uniform speed velocity. You could say velocity at uniform velocity unless an external force acts on it. Yay! All right, and then it says carriage in free fall. Free fall sounds like gravity, so gravity acting on that carriage will speak in terms of acceleration. So that sounds like Newton's second law. And Newton's second law states that acceleration is directly proportional to the force of an object, but is indirectly proportional to its mass, where acceleration is equal to force divided by mass. So those are the first. So Newton's first law and Newton's second law. And as we turn over, this is where you start to cry a little for your mommy. And it says, calculate the length of time that the carriage in part A on page 14 is allowed to free fall if it reaches a speed of 64.8 kilometers per hour from rest. So we need to calculate the time. It says calculate the time. So we said t equals to x. Allowed to free fall. So in a free fall, acceleration must be 10 meters per second squared. And then it says reach a speed. So velocity is 64.8 kilometers per hour. You want to convert that to meters per second. You multiply by 5/18. And why is that? Because if I were supposed to convert it, I want to convert the kilometers to meters. So that's by 1,000 meters divided by the hour times the hour. And in an hour, how many seconds are there? 60 times 60, which is 3,600. If you take that 1,000 and divide it by 3,600, which is what you see here, because if you cancel this out, you will end up with 64.8 times 1,000 meters over 3,600 seconds. If you take this bit out, you would see that you end up with 10 over 36. And this 10 over 36, 2 into this will give you 5. And 2 into this will give you 18. Right? So this is 5/18. So you just multiply by 5/18. And you will get 20 meters per second. Okay? So I'll show you if you do that. It says 64.8 times 5 divided by 18. Oh, sorry, you get 18 meters per second. Okay? So that's V, and then it says from rest. So rest is 0 meters per second. And we all should know our four equations for what is in motion. We have V equals to U plus AT, V squared equals to U squared plus 2AS. We have S is equal to U plus V times T over 2. And then you have S is equal to UT plus AT squared over 2. Now we want to find out which one we're going to use. It's kind of obvious, but I'm going to show you how to do it. We're looking for time, so we want to eliminate all those equations that don't have time. And that one is number 2. This has time, this has time, this has time. We want to have an equation that uses acceleration, so we're going to eliminate all the equations that don't have acceleration in it. And so this one doesn't have, but this has and this has. So we already eliminated 2. We want an equation that incorporates velocity. So we're going to eliminate all those equations that don't have velocity. What is left? And this is the only one without velocity. And what we're left back with is V equals to U plus AT. Since we have V and we're seeking T, we're going to solve for T. We're going to transpose. So V minus U equals to AT. Divide by A on both sides. So now you know T is equal to V minus U over A, and you fit in all. So it's V is 18 meters per second minus U, which is 0 meters per second, divided by 10 meters per second squared. And that will give us 18 meters per second over 10 meters per second squared, and this will give us 1.8 meters per second times seconds squared over meters. That goes, and now we know that we have 1.8 seconds. So I hope that helps. Then it says determine the distance the carriage falls. So we know that we have T is 1.8 seconds. A is 10 meters per second squared. V is 18 meters per second. U is 0 meters per second. And now we want distance. S represents distance. So looking at these up here, we know that only 3 of these have distance in it. We have 2, 3, and 4. So I'm going to write them back. V squared equals U squared plus 2AS. S equals to U plus V T over 2, and S is equal to UT plus AT squared over 2. So we're looking for an equation that we can use the easiest. V U squared 2AS. We're looking for S. So really and truly we don't want to stick with any exponents, but either one of them will give us the same answer. So all of these we can use. So let's try V squared. So V squared equals U squared plus 2AS, and what we're solving for is S. So we're going to say, if we use 1 here, we say V squared minus U squared equals to 2AS. Divide both sides by 2A. So S will be equal to V squared minus U squared over 2A. S equals to, what is V squared? 18 meters per second. U squared is 0, so we could ignore that. And multiply 2 by 10 meters per second squared. What we will get is 18 times 18 divided by 20, 16.2. 16.2, we have meters squared, seconds squared, times seconds squared over meters. Remember, when you're dividing by an fraction, you have to upturn it. So we get rid of this, so we get rid of this and this. So our unit is in meters. S equals to 16.2 meters. We could try this one. So we know we're looking for S. So it's already saying S equals to, so S equals to U plus V T over 2. So we could just solve straight. So S is equal to, what is U? 0, so we could ignore it. This is 18 meters per second, and time is 1.8 seconds over 2. So we're going to say 18 times 1.8 divided by 2, 16.2. So we have 16.2 meters, because this is going to cancel out that. Then we're going to try it with equation 3, and it says S equals to UT plus AT squared over 2. So we know that U is 0, so this is going to go away. So it's going to be S equals to AT squared over 2. S equals to 10 meters per second squared times 1.8. Wait, what's the time? Yeah, 1.8 seconds times 1.8 seconds, called it T squared, divided by 2. The S here, we could say 2 into 10 is 5, so we could put 5 times 1.8 times 1.8, 16.2. So I have proved 3 times that the answer should be 16.2, and you should get a total of 15 marks. Okay, so question 5 is a lot of literature, so I'm not going to waste any time writing it down, but I'll read the question first. So it says, 4 factors of the surface of a material on which absorption and emission of radiation depend are texture, nature, color, area. It says, state with a reason the appropriate characteristics of 2 of the above factors in the design of a car radiator and the roof of a Caribbean home. Now, if you don't know how a car radiator look or what it does for the car, you will probably solve for this question, or you would have been if this were the question that comes. So I would suggest that you look up things that are all physics based, like how a car works, how a motor works, how a generator works, how a greenhouse works, all those things, how a solar heater works. I haven't seen in the book how a car works, but they dropped this question. So try to think of things that required physics to make them. How a plane works, look up that. Look up all of those things today. Because you don't know, they might come and say, the turbine for a plane incorporates the and you're just like, I don't even know what a turbine is. Oh my God. So look up these things that you know will include physics to make them. So for the radiator of a car, I would include the area and the fact that it's shiny. Now for you, there's a car. This is a car. Trying to draw a car here. My hand just went leave me. The radiator is found in this section right here with a fan right in front of it to blow it. And so you would think that the radiator is used to remove heat from the car, so you don't want the car to overheat. The radiator is large, so I would say the area of the radiator is large to allow maximum heat loss so that the car does not overheat. And it's also shiny to reflect heat away. So those are the 2 right there. So the car don't overheat. So I have the reason and I have the explanation. Now the roof of a home, first of all, we use galvanized here in St. Kitts. How did I know that all the roofs in the Caribbean use galvanized? How did I know that St. Kitts didn't change? I don't know. But the majority of homes in the Caribbean use galvanized. So I would say that, first of all, galvanized is shiny, and shiny to reflect heat away. And it's also, the area is large. Area is large to not reflect, but it's shiny, yeah, but to allow maximum heat loss, right? So it says, so that in order to keep inside of the homes or houses, whichever you want to call it, cool or livable. You want to be able to live inside the house, comfortable, so that living is comfortable, right? So shiny to reflect heat away, area is large to allow maximum heat loss, and in order to keep inside of the homes or houses cool so that living is comfortable or bearable. And we turn over and it says, the following data were obtained in an experiment using an immersion heater to determine the specific latent heat of vaporization of water. It says, using the data above, calculate the specific latent heat of vaporization of water, assuming negligible heat is lost to the surroundings. So, first of all, you must remember, once you involve in something called immersion heater, you're thinking about power, and you hear power and time, you put all that down. You must remember all of these. Look in, PT is equal to EH, therefore PT is equal to MCAT. PT is also equal to my love, and PT is also equal to MILF. PT also equal to MGH, which is potential energy, and PT is equal to mv squared over 2, which is kinetic energy, right? But in this case, we're dealing with latent heat, with specific latent heat of vaporization, and so we're going to deal with this equation here. So we're saying using PT equal to MLV, we're going to write down everything that we have. So we have power, which is 150 joules per second, because 1 watt is equivalent to 1 joule per second. And we're using that because we have to convert this to seconds. Time is 5 times 60, because 1 minute is equal to 60 seconds, so 5 minutes would equal to 5 times that, which is 300 seconds, yes. And then we need to find the mass. So the mass would be M1 minus M2, because we need to determine how much water vaporized. So the mass is equal to M1 minus M2, which is 0.28 minus 0.26 kilograms. Put that in that, which is equal to 0.02 kilograms. Then we're going to work it out, and we have, since we're looking for LV, which is the latent heat of vaporization, we divide both sides by mass. And we know that LV is equal to PT over M. And we just fit it in now. So we say 150 joules per second times 300 seconds divided by 0.02 kilograms will give us now 150 times 300 divided by 0.02. and we get 225,000. 1, 2, 3, 1, 2, 3. So 2,250,000. So we have, oh my God, I'm thinking about money. I wish it was money. So 2,200,000. I put the dollar sign. Joules per kilogram. And that would be your answer. If you want to change it to kilojoules, you just divide by 1,000, and you're gonna get 2,250 kilojoules per kilogram. Right? Turning it over, it says the coil of the immersion heater was not completely submerged. Explain how this would have affected the value for the specific latent heat of vaporization obtained in B1 on the last page. And this is what I have. The coil not being fully submerged may have caused less water to vaporize in 5 minutes, thereby causing the experimenter to obtain inaccurate results. This in turn will cause the experimentally determined specific latent heat of vaporization value to be smaller than it should be. Okay? So here ended the scripture reading on question 5. See you around for question 6, which is the last question on this test.